This is going to be actually a little... Okay, so I don't have to be right next to it. I'm good? That's good. Okay, show of hands. Who here likes watching presenters switch back and forth when they're doing a joint talk? Yeah, I didn't think so. I'm going to borrow a trick from a coworker of mine. When you see us switch places, cheer like mad. Just go nuts. Seriously. Okay? Let's try it.
The power.
Power of a captive audience. All right. I went to school for software development. I've been writing automation software for most of my career, but as an SRE at Heroku, I'm debugging relationships, process hacking using I feel statements. SRE at Heroku is about so much more than writing code and designing reliable, highly available systems. And I love it, and I'm going to tell you why. Quick warning, this talk contains one swear word that the FCC allows you to say on the radio. Why isn't it? I'm Lex, this is Courtney. We are SREs at Heroku. Heroku is a platform as a service. We make it super simple for you to deploy your application, and then we run it for you. It's like operations as a service. Our job is to keep your application running all the time. Reliability is incredibly important. We have 130,000 requests per second. There is no low part of our daily traffic graph. There we go.
So we use something that we call total service ownership, or the total ownership model. And the first time I heard that phrase, even though I had been doing it for some years at that point, this was my reaction. If you've heard me speak before, you've probably seen this slide. I really like that picture. I think it's really cute. It also completely exemplifies my sort of deer in the headlights feelings. What this means is when developers are responsible for the operation of their code in a production environment. Sorry about the quality of the graphics here. Companies operate in hierarchies. They disseminate vision and direction from the top, and they attenuate pushback. This is what a hierarchy is designed to do. If operations are offloaded from developers onto another team, it separates developers from the feedback on what they've created. This is what I talked about all yesterday, so there's some review here. Sorry if you are in both places. Operational pain and feedback are absorbed by a team with a limited ability to respond and create improvements. Companies feel like they have to do this for support, so it seems super reasonable to do it for operations too, but this keeps the developers from understanding the consequences of their actions. When developers are responsible for the success of the production environment, they get clear feedback about what's working and what isn't, because the pages go straight to them instead of to somebody else who can't fix things. So you can see that I'll swap back one more so you can see better. Pages, not going quite as far here. Pages, go a little bit farther in this diagram. If you add SRE to this, that's where I have trouble displaying this in 2 dimensions. The way an ops team can tune a service, an SRE team can tune an organization. SRE with a total ownership model changes the interconnections in your organization and helps put incentives in the right place. We can amplify back pressure when needed. We can make successes, failures, and the state of the world more visible. Our team has existed for 2 years. It took us a little while to find our place.
Okay. And I can calm, as an ops person, I can calm the hell down because I know that developers have the same motivations that I do. They want to keep the service running, if only because they don't want to get paged in the middle of the night. In a traditional ops organization, you have a throw-it-over-the-wall model. Development ships, moves on, and lets ops run it. Ops' job is to say no, or at least that's the job they find themselves in. Development isn't set up to consider operational concerns. Development has all these pressures from vision and strategy to ship new features. Ops has the operational concerns. Protect the service, protect their pager burden. Ops distrusts dev because dev is the source of ops pain. So ops blocks dev from releasing code that's not reliable. And dev gets annoyed. Dev distrusts ops because ops blocks them from doing their job. And the result is an opposition between ops and dev. Some organizations try to get around this by empowering ops to say no harder. This just makes the opposition worse. You have a knowledge gap. Ops is on call for a service with little or no information about how to run it. You have resentment and panic. Ops has all the responsibility with none of the knowledge. There was this time a couple of jobs ago where we had acquired a company and Ops had inherited the privilege of running their code base, and it paged me in the middle of the night. Well, middle of the morning, actually. And I didn't know the first thing about this. I knew it was down because it said it was down. I didn't know why. It was running on some platform as a service that I had never heard of and didn't know how to use. It was running on Heroku, and I didn't know Heroku at the time. So I paged the developers. They didn't answer. I paged the manager for that team. No answer. These people didn't have a real pager rotation. I pulled out my org chart, looked at the next person up, the vice president. I paged the vice president. The vice president said, okay, thanks for letting me know about this. I think we're going to have to leave it down until they wake up. In a situation like this, operations, once they do get a hold of a developer, will sort of hang on to them for dear life. I would find myself not wanting to let go of a developer that I'd gotten in, even if they told me that the service was going to recover, because it was so hard to get them in the first place. I wanted to make sure until I could really trust this thing was not going to go down again before I let them go. At Heroku, as a newbie, I had to remember I can and should let developers go. They have a real pager rotation. The system will page them back in if it goes down. And I can always page them back. Letting developers go prevents burnout, and we'll talk later about why preventing burnout is so important. Saying no to developers to block pain in ops doesn't scale. If you have multiple developer teams trying to ship things, you'll end up with something like this. A developer says, hey, I want to ship this code. Ops says, OMG, this thing is not scalable. Please don't run it on my infrastructure. The developer says, well, hey, look, there's a server over there. I'm just going to chuck it on this. A server. And pretty soon, before you know it, you've got Poo running on an old PC, a Spark station, and your toaster. This is a reliability problem. Ops' approach here is flawed, and it results in a less stable infrastructure. So how do we avoid the poo? Don't say no as an SRE. Even if what you mean is no, say yes if. If we make it more scalable, if we add some redundancy, avoid negativity, because negativity creates that opposition we're trying to avoid. Call out successes when something really reliable gets deployed. People will listen more if you're positive, and less if you're negative. Disseminate and encourage best practices. SRE is well situated, as Courtney pointed out, to see the common patterns that lead to reliability and to alleviate friction that causes developers to resort to hacks. Don't dictate, provide evidence. Win hearts and minds. And if it doesn't work and something unreliable gets deployed, remember that the developer teams will carry the operational burden. They'll get paged for it, and the situation will self-correct. The negative feedback from the service will result in the changes that SRE wants to see. I see you're bored now.
SRE needs a holistic view. Anything that affects reliability is in scope for SRE. I work on cool stuff like perceived job security, engineer morale, and vendor relationships. A major argument against the total ownership model is pager fatigue. I'm sure that many of us in this room have had evenings and mornings and afternoons that looked like this. This is a reliability risk. Tired people do make mistakes, but the answer isn't to concentrate all of the pages on a team that does nothing but take pages and fall asleep at their keyboards. The way to look at pager fatigue is as an expected failure mode. Pager fatigue is what happens when you're running too close to the edge. It's a signal that things in your organization need to change. That's because the end state of pager fatigue is burnout. SRE is uniquely placed to catch pager fatigue becoming burnout. Once people are talking about burnout, that means things have been bad for a long time. People don't get burned out over the course of hours or days or even weeks. Usually it takes a long time of too many pages, not enough sleep, too much on-call, too much vigilance. It's a process that happens over time with work, stress, and hours. Burnout is after all of the small to medium signals of a problem have been missed.
An exhausted, burned out on-call staff is a reliability risk. They make mistakes, they aren't on their game, and they miss pages. Reliability risk means that SRE should be paying attention. SRE is well positioned to gather information about on-call pain and create and disseminate best practices. In SRE at Heroku, we promote work-life balance because it improves reliability. This doesn't mean working at home in the evening after you've gone home. It means actually logging off for the day. We use the buddy system for our on-call. You always have someone to back you up. We try to adhere to 4-hour incident response shifts. If you get paged and you're still there working on it after 4 hours, tag in your secondary. We found out that after 4 hours, people are more likely to make errors that compound the incident. You won't necessarily even realize it if you're tired. The person who's in the situation is least well situated to tell how tired they are. Burnout leads to attrition, and attrition is a reliability risk. I don't want to have to backfill your ass. When people leave the company, they take knowledge with them. They shrink the on-call rotation. Keeping systems running 24/7 is stressful, and we often forget that. We owe it to ourselves, our coworkers, and our companies to avoid burnout. Overworking doesn't make you a hero. It just makes the system less reliable. You're not doing anyone a favor. Tired people make mistakes and they aren't working their best. We should encourage each other in self-care, time off, etc., and SRE should champion this because it improves reliability. I am annoyingly persistent about telling my colleagues not to overwork themselves. I tell them to GTFO. Don't work 10-hour shifts. Don't check your email out of hours. Don't spectate incidents that you aren't responding to. Don't check your IRC or your Slack when you're off hours and see something is blowing up. This is incredibly tempting, and I have to sit on my own impulse on this one.
SRE at Heroku are the product owners for incident response. We're involved in every incident and every retrospective, so we maintain the protocol for how all of those things happen. Changes in the process primarily affect us. Because we're the incident commander, we're running the incidents anyway, we simply guide other responders through changes in that protocol, which is why it lives with us. The exception to this is changes to the when to page SRE part of the protocol, because we can't just guide people through when to page us. We're not there yet. We haven't been paged. So we socialize this aggressively through email, Slack topic lines, and Slack flagging. We think of incidents as a life cycle. From when the impact starts through the actual incident response and to the retrospective, including the remediation items that we come up with out of the retrospective, and we hand those off to the teams who would need to make the changes that we've come up with. SRE determines what the criteria for an incident are, when to open a public incident and when to close it, when we need to have retrospectives and when we don't, which is honestly not very often, and what the criteria are for a public apology on our status site and an explanation of why things went that badly wrong and what we're going to do to prevent it happening like that next time.
Under the total ownership model, what is SRE's role in an incident response? SRE coordinates incidents. Development actually fixes things. SRE pays attention to holistic platform health. Development teams pay attention to the health of their individual components. SRE handles incident coordination. Development handles incident response, investigation, diagnosis, etc. SRE handles user impact, as Courtney mentioned. A technical background is still vital for SRE. We have to understand what development is doing during an incident and how the systems fit together. At Heroku, SRE's role is the incident commander. This is a concept borrowed from the FEMA disaster response protocol and is also used by Salesforce, our parent company. The incident commander does not fix the problem. That's development's job. We have a holistic view of the incident response. This frees up developers to work on just the component that they know best. SRE coordinates multiple teams. We avoid duplicate or conflicting work. We look for impact spreading to other components so we can bring in more teams. We identify the full scope of user impact. and we drive toward a resolution of user impact. That is the most important thing, not finding out, the deep intricacies of what went wrong and why. We queue up external communications by bringing in a member of the support team to post on our status site. We deliver a concise summary of user impact to them so they can make their post. We proofread and verify their posting for technical accuracy. We manage resources in the incident response, keep track of who's doing what, and try to prevent burnout. We remind people about those 4-hour incident response shifts, although we don't enforce it. And we can set up shift rotations for teams and for the IC role itself for long-running incidents. The incident is over. Now it's time to look back. We do an incident retrospective. Why do we do a retrospective? The goal is to prevent recurrence of the incident. If you don't run a retro for a given incident, that's tacit acceptance that that incident can reoccur. Maybe that makes sense for your organization. In most cases that I've seen, it doesn't make sense. On Monday, we did a half-day tutorial about running retrospectives. We'll submit a proposal next year for LISA16 to run another one. If you're interested, keep your eye out. We had a lot of fun, and we'd love to see you there.
Story time. Seattle has the 2 longest floating bridges in the world, and in 1990, one of them sank over Thanksgiving Day weekend in a storm while it was being repurposed. No one was killed or injured, but it was a giant disaster and it required a giant investigation. The public reporting to this day is extremely simplistic, but the official investigation found that there were 5 factors involved and that all of them were required for the bridge to fail. What was happening at the time that it went down, they were scraping off the surface of the bridge in a process called a hydrodemolition. They were going to take it from a 2-way span to a 1-way span because they were building a separate span nearby, and they were going to basically double the bandwidth of the bridge. They had originally been letting the water run off into the lake, and the EPA was like, oh my God, you can't do that. That's contaminated. You need to truck it away and deal with it. So since you can't leave water lying around on the ground in piles, that's not how water works, they had to figure out a container that they could put it in. Floating bridges, it turns out, are made of hollow concrete pontoons. So they decided to store, I can see the face palms already. They decided to store the water in the pontoons before, as a staging area, as a buffer for trucking it away. When the storm happened, one pontoon started taking on water and sank and slowly dragged 7 more down after it. This was a nested, slow cascading failure, which I am enough of a nerd to think is really fun. The University of Washington put out a paper on the investigation, and this is the shortest amount of text that you can have that describes what happened to the bridge. And I'm actually going to read it because it's important and interesting. The loads that created significant leakage were the combined effects of all accumulations of water, including rain after the windstorm, longitudinal flow on the surface of the bridge, that's rainwater that was rushing back and forth on top, and pumping through November 24th, 1990. These loads caused static moments, that's to say pressures, that exceeded the threshold for leakage. Existing cracks in the pontoon were open sufficiently to allow water to leak in. Progressive and accelerated sinking began at this time. What they found was that there were high and low points in the bridge from the way that the pumping schedule had been followed. The bridge was unevenly filled with water, so they had more water here, less water there. It put torque on the joints of the pontoons. They had also found in their initial survey, the bridge was floating much higher than it was ever intended to. It was in really good shape. There were cracks in the bridge. They were non-leaking. The structure of the bridge was extremely sound when they began this work. There was nothing to make them think that they were going to have any problems with the work that they were doing. And it had lasted through its years on the lake extremely well. So they measured how much extra flotation they had. They added an error budget. They calculated very carefully what the pumping schedule should be, how much water should be in the pontoons in order to be safe. What happened with the stresses is that it twisted the first pontoon enough that cracks in the bottom opened up enough to draw in lake water from underneath, which started to sink that pontoon and drag the rest down after it. So that seems like a really thorough investigation, right? We covered a lot of factors. We discovered that there were a lot of things that were required for this bridge to fail. But they missed something big. The crews were having trouble keeping up with the pumping schedule. That's why we had high and low spots on the bridge that created this torque. And as far as I can tell, this wasn't investigated. And if anyone did investigate it, they didn't write it down. So we're never going to know why something about the organizational structure of the people working on this bridge caused one small problem that compounded with a bunch of other environmental factors and a 100-year storm to sink the bridge. Complex systems have complex failures. No one human action can be the cause of a failure in a complex system. So let's do better. We use a template for our retrospectives. We have written a Google Doc that guides the facilitator through all of the parts of our retrospective so that we don't miss something like the investigation of this bridge mast. We have prompts and examples in the template. We're running a fine line between enough words to help and too many words so that they're confusing. This is something that we wind up tweaking a lot based on watching how retrospectives go and feedback from the people who are using it. We've done a lot of iteration on this template.
Let's say developers are taking down production because their cats jump on their keyboards and press enter and deploy code before it's ready to go to production. We don't just call that feline error and move on. We need to do something about it. It's not just about the technical details of a failure. What's wrong with the infrastructure or the monitoring or alerting, of course that's important. It's also about the environment in which these things exist. And we have to examine that environment carefully if we really want to prevent recurrence. This can mean that SRE finds themselves pushing feline policy. Stories in the news often say that a problem occurred due to human error. We can't just stop there. Human error is actually where your investigation should start. That's where things get really interesting. People make the best decisions they can with the information they have at the time. Nobody's trying to be stupid. So what aspects of the system allowed the error to be made? Can we change it to make errors less likely or impossible? When you start digging into this, you'll find all sorts of interesting causes. Many of them are non-technical or cultural in nature. To remediate this kind of incident, you need to change the system. To handle mistakes, because people will make mistakes. That's how people work. We need to design a system to be resilient to errors. We design our systems to be resilient to a failed hard drive server, even a whole data center. Why don't we design our systems to be resilient to human errors? To make mistakes, we need to make mistakes less easy or impossible. To do this, we can use automation to expose mistakes before humans can catch them, or to prevent mistakes in the first place. Sorry, to expose mistakes before they're made so humans can catch them. It's tempting, especially in a retrospective, for computer people to consider other humans as substandard computers when they make mistakes. We can't get rid of humans, and we shouldn't try. They do things that are difficult, expensive, or impossible for computers to do. We should make computers do what they're good at and the humans do what they're good at. SRE can help organize and design the process to handle the way that humans work. A human is like any other system in your infrastructure, just a little bit squishier. There's a fallacy. Well, now that we know about this kind of mistake, we can just not do it again. Just make a better process, train people better. Blame, shame, and retrain is the phrase often used in the safety community, and it applies here too. Say an engineer, well, we had an incident actually earlier this year where an engineer, one of our engineers, typoed a version number during a deploy. He was aiming for 986 and got 862. It's not just like, hand shifted over. This was just a total fat finger. That's what he said. Whoops. It was a pretty bad incident, actually. See if you can guess which one it is on our status site. So do we just tell our engineers to check their version numbers more carefully? Well, how did this really happen? Rolling back 100 versions accidentally when you're trying to roll forward one is probably not what the engineer intended. The system, the tooling, should at least prompt, if not actually prevent this kind of action. Say, are you sure you want to roll back 100 versions? If the engineer actually wanted to roll back, they didn't, they wanted to roll forward, they should probably type a command that says rollback in it. And so if they're putting out a version that's earlier than the version that's currently out and they're not doing a rollback, the system can say Looks like you're doing a rollback. Do you want to use the rollback command? That kind of thing. Depending on humans to avoid errors, even errors that specific human has made before, is unreasonable. And it's a reliability risk. It tries to treat people as computers that infallibly follow instructions rather than humans that by our nature make mistakes. It doesn't work and the error will happen again. This is especially true the larger your infrastructure and workforce gets. It's critical that your retrospective process is blame-free. Why? A human root cause is inhumane. Any human could have made this error. A blameful retrospective is a reliability risk. People try to shed blame to avoid repercussions, which is a reasonable reaction to the system they're in, especially if they're worried about getting fired. So they'll withhold information even unconsciously. But that information is critical to finding out how you can prevent the incident from happening again. Engineers must feel safe enough to explain their motivations and decisions, what went into making that decision. Remember, we all have the same goal, improved reliability. Also, people will self-blame, so don't add more blame. It's important to note that it's still okay to talk about people making mistakes. In fact, it's critical to get to the heart of what went wrong and how to fix it. But we must remove the stigma from making a mistake and repercussions. None of this stuff is new. A few fields have been saying stuff like this for a long time. Medicine, aviation, fire incident response. We used to have a lot more plane crashes than we do now. Aviation made a seriously concerted effort, and now it's incredibly safe. It's very unlikely for a plane to crash. We can learn a lot from these fields because they've been doing this for much longer. I am a total incident nerd like Courtney. I love reading about how incidents occurred and what folks are doing to fix their systems and make it not happen again. I read about surgical accidents, etc.
Humans created everything in your infrastructure, which means that all problems are human problems. Literally everything that exists is the way it is because of a human making a decision or many decisions. This means nothing is immutable, even though some things in your organization or your infrastructure may be stuck and difficult to change. Do you see the date there? That's 1968. We've known this for quite a while. Melvin Conway is a programmer who documented the principle. It's become known as Conways Law. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. This means that every product contains the rough edges, disagreements, disappointments, and miscommunications of the people in your org. We can apply this in reverse. We can try to fix the problems in the organization in order to improve the product. My job is applying Conway's Law in reverse in this way to my organization to try to improve what we put out for you to use. All organizations have org charts and hierarchies, as I discussed before, but they also have unofficial connections. It pays to have a feeling for interpersonal networks and make the effort to maintain your own, the sincere and genuine effort to reach out to other people in your organization to make personal connections. This helps people feel comfortable exposing risks to you and gives you a chance to notice organically when teams are struggling. When I was an undergraduate, I was part of the student-run campus crisis hotline at my college. We did something that I have not seen before or since. We encouraged people to call us about anything at any time for any reason, not just because they were upset, not just because they were failing, not just because they were in crisis, but because they wondered, what is that concrete head out on the Esplanade? Like, who is that person? Why is there a head there? It turns out that's Arthur Fiedler, by the way, and his head is there because he pioneered open-air classical conferences in the Hatch Shell, which his bust is near. And that is a question that I actually answered when I worked for this crisis hotline. The theory was that if you call us for routine things, when you just need to chat, you're just curious about an answer, then you have had the experience of talking to us and knowing that we will treat you like a person and we're not going to laugh at you and we'll take whatever it is that you're saying seriously. And you've done it once, maybe even you've done it several times. So maybe when you're sincerely in trouble and you don't know who to talk to, it will be easier for you to talk to us because you've tried it once and it worked. Everything is a people problem. Figure out how to love and support your people. Thank you for coming.
I think we have time for Q&A maybe?
Yeah, we certainly have time for questions.
don't forget to come up to the mic. Real quick, I just want to plug a personal project of mine not associated with Heroku, SRE Weekly, sreweekly.com. It's my weekly newsletter for all things SRE, not just reliable systems, but all the stuff we just talked about. It's really fun.
If you...
It should be on. Here you go.
It should be on? Okay. If you have more of a comment than a question, come up and talk to us later so that we can handle questions at the mic in front of the room, please.
We should manufacture some questions.
So I have one question, which is just, does it make a difference if you're a tiny startup or a large organization with a lot of personnel resources on any of these issues? Are the constraints of abusing or using humans different in those cases, would you say?
I think so.
So some of you may have been at my talk yesterday. Someone came up to me after that, which was mostly focused on the total ownership model, and said, you mentioned Amazon, and we've had this discussion sort of in the tech community about the way that Amazon treats its employees and the way that they are always driving to innovation and the pressures that that puts on people. And with any organization, you still have cultural problems that come from the top, right? Like, we're talking about ways that you can set up the organization to try to make things better if everyone's job or everyone's goal is to improve the human experience of our customers, ourselves, each other. You still can have the problem where that's not necessarily everyone's goal, and that can be supremely amplified in larger organizations. And then, of course, you always have the problem of, like, the consensus is harder to achieve in a larger group. So yeah, it's different sizes of organization do change how this works, but it doesn't mean that it doesn't work. It just means that you have more to do.
Can you give us a definition of what SRE is and the benefits?
I meant to do that. Here, I'll do it. Sorry, service or site reliability engineer or engineering. So site reliability engineer, it was a term pioneered by Google, I guess, sometime a decade ago. It's their take on ops plus a development background. So it's doing ops, but as a software engineering kind of discipline, writing automation software to handle large swaths of your infrastructure, that kind of thing. Totally meant to do that on the first slide. Thanks.
So the website that you were talking about will give us more information about that?
I don't know if I actually define SRE on sreweekly.com, but I probably should if I don't. If you want to learn more about SRE itself, type SRE into Google or type Site Reliability Engineering into Google. You'll probably end up with Google's docs on this stuff, since they're the ones that are pushing this. They also have an entire book about it at their booth, the Site Reliability Engineering book, and I think they're raffling off signed copies.
Okay, thank you.
It's probably worth being clear that what we're doing at Heroku, what we just told you all about, is not exactly the same thing that Google does.
Yeah, actually, it's quite different from what Google does. They have a huge team of SREs that team with their developers to try to design reliable services. Now, we do that too. We have a lot of ops background in our team. I've got like 7 years of ops background, and I often am called upon to help debug problems that are overarching cross development teams, or help them design reliable stuff. But what we do is definitely different from what they do, because we're doing that whole people-oriented thing. Question?
The SRE book has an interesting concept about risk budget. So it's a way of letting ops say no, but they don't really say no. It's you who throttles your own risk. So I thought that was a very interesting way of balancing that.
Yeah, in previous iterations of this talk, we mentioned that. They call it the error budget or risk budget. The idea is that a developer team that has some service has a goal of like 99.9% uptime, and that is not only trying to stay up that long, but you're actually allowed to go down 0.1% of the time. If you think about it, velocity of deployments and reliability are in some ways at odds with each other. The faster you release code, the more likely you are to release buggy code. And that means that if you really want to be super reliable, in theory, you never release code. You have 3-year release cycles or something like that. Doesn't necessarily actually mean you're going to be more reliable, but it probably means at least, there's some correlation there. That's really interesting stuff, and it really comes down to the core of what we're talking about here. Is just, concentrating on the goal of reliability. Yeah. Do you want to take anything more there? We good?
Yeah.